What happened last time, we're going to look at the last problem, and similar to that one. So this will be number 3.
So all 4 of you.
So what was the last thing we did? Just quickly, make sure.
So I'll take square leaf for 1 second.
Okay.
So you'll download the one for today.
All right, thank you. So the last time, so we had the problem number 2, and there were 2 questions in that example. One was to approximate the area with 6 rectangles from the right. And then the B part of the question was to find exact area. So pay attention to this problem because similar problem will be on the exam. And as I told you, I'll give you formulas, but everything else is yours. And you will have a question where you have to approximate, and unless you have a question, you have to find exact area. So that's that one. The next thing what we're going to do, we're going to find the integral. Let's say we have it from 0 to 1, square root of 1 minus x squared dx. So as you saw with the previous example, we can find this integral, which is the area, right? Yes, no? At least putting on the picture. We could do this through the limit. That's one way of doing it, which is not the best, not the most efficient way of doing it. But when we apply the concept, yes, we can do it. The other way of doing it is actually to look at this integral from the picture point of view. Meaning this, you look at your function, which is, let's say, g of x equals square root of 1 minus x squared, and you graph this function. Maybe using your graphing calculator, or maybe you know what this is. So, for example, if you use your graphing calculator, what you're going to see, if you graph this, you're going to see the semicircle. So we'll go from -1 to 1. That's the graph of this function. And you actually can find the area under the curve just by using formula for the area of a circle. The only thing what you have to be careful here with your upper and lower limit. Our interval is 0, 1, right? So what that means, you don't look at this picture from -1 to 1. What you're looking at, you're looking only at the quarter of it. And then it's easy to know what that is. The area or the integral will be pi r squared, right? That's the area of entire circle, and divided by what?
2.
Divided by 4. Why? Because you're looking for only one part of it, right? Just a quarter of it. Well, so again, do you understand why we're dividing by 4? Yes, no? Minako?
Yeah, we
Yes.
got it.
Yeah.
All right, just want you here that you still there. Okay, so again, we're dividing by 4 because we need only the quarter. Well, and what's the radius? 1, right? So you will have just pi times 1 squared divided by 4, and it will be just pi over 4. So when you will be working on your homework assignment, they will have specific questions where you actually have to graph the function. It will say find the area or find the integral, interpreting it in terms of area. That's what it means. In terms of area means, or areas, means you get your function, you graph it, you look what shape you get, and based on the shape, you're applying formula from geometry. Circle. The next one, let's take a look. B, similar to this, we have to find integral from 0 to 3, and we have of x minus 1 dx. Again, there's a specific question. You have to work with the question, not like what you can do. Because when we get to the end of chapter 5 and then 6, you will know more than just graph it. You will know algebraic approach or calculus approach to this integral besides just using limits and maybe graphing. But this question is specifically saying, get your function, graph it, look at the picture, and then use geometry formulas, find the area, and that will be the answer. So when we graph this function, which is, if you want to put it separately, f of x, let's say, is x minus 1, you all know that we have a line, and starts at -1. Again, I shouldn't say starts, but -1 is y-intercept with the slope. So we will have a line. And basically, we have a segment because we are limiting everything with the interval. Do you understand the picture? Okay, so from 0 to 3. But the next question, can you shade the area that we're looking for? For example, you have this. And next, you have to shade the area. Can you shade the area?
Yes.
Okay, do it. I'll give you a couple seconds, let's say. Shade, and then we'll see if it's right. Because students have different ideas here, what they really want to shade. So remember, we're looking for the area under the curve on interval from 0 to 3, and my curve is this line. Well, you should have it by this time. So if you have it, the right answer is this. You have two triangles. One is right here, and one is right here. Did you get that? Okay. So if you have this, that means you're doing everything right. So basically what do we do now? We find area of these two, or areas, right, of these two triangles, and then we'll add those two. So let's say this will be A sub 1 area, and this will be A sub 2. So if you are looking for A sub 1, so 1 over 2 times, what's the base of this triangle? A sub 1, this triangle. 1, here's your base, right? The next question, what is the height? The height is -1. And you should know that the area will be negative, right? Because the triangle is sitting where? Below the x-axis, right? So we'll have -1 over 2. So that's the area of this one. Now moving to the next one, 1 over 2 times. So the next step, what's the base?
2.
2, right? Our intersection here is 1, x intersection. So we'll have 2 as the base. Now, by the way, it's not always, sometimes when you graph the function, it's not always like 1, 2, those good natural numbers, okay? Sometimes it can be like 1.5. Okay, you understand that? It doesn't have to be 1. So you really need to know this number right here, the intersection. Okay, so base is 2, what's the height?
2.
2, how do we know?
By graphing.
Okay, you can say that too, or what? You take 3 and substitute into your function, right? To get y value over here.
2.
So it's 2. So we calculate this. We'll have 2. So the total area is addition of these two, a sub 1 plus a sub 2, right? So you will get -1 over 2. And what? Plus 2. So the area will be what? 3 over 2.
3 over 2.
Any questions? Doing fine?
Yes.
Okay. So let's do one more. And I'm going to bring absolute value. Because you like absolute value. So we go with the integral. Let's do the same thing what we just had with B question, except instead of having our x minus 1 as the function, I actually like to put absolute value of x minus 1. Now, overall, it's easier to find this integral by actually graphing it, not using procedures that we learn in the future.
Okay.
Hey, but
Okay? It's much easier, again, to find this integral by graphing than actually going with the procedure. Again, I want to repeat, when we had absolute value, the last time we talked about limits. And I told you, you cannot find the limit if you keep absolute value. You have to get rid of it. Exactly the same in the future. You will see that this integral cannot be taken just like this. You actually have to get rid of absolute value. So, the good thing here to remember that we can solve this by graphing. So, the function again is f of x equals absolute value of x minus 1. And you can go to your calculator again, graphing calculator, and graph the function. Now, do you know where to find absolute value on your calculator? Yes? No? Miniko?
Yeah, we figured it out.
So yes or no?
yes.
Yes. You know.
Alright, so you go to math, and then shift to the right, to numbers, and you and the first one says A, B, S. So hit math, okay, and go to the right, and A, B, S. Now, again, there's no such thing as two vertical lines in the computer world, okay? Same thing you do with any programming language, C++, Java, Perl, whatever you're learning, let's say, if you have to, maybe in the future, you have to use abbreviations. So, going to your calculator, working with ABS, when you graph, this is what you're going to see. Do you see it? If you have your graphing calculator, okay? I don't know if I have to pull it, but see, it's not that difficult, I can do it. So what I said again, you go to mathematics, go to the right one, and the first one, A, B, S, says absolute value. And then you put x minus 1, and you graph it, and this is what you have. Okay, now we can zoom in. Okay, I know zoom 2 will be good zoom here, but let's zoom in and see if that helps us. Not the best because I don't see 3, but it's a little bit to the right? If you look at the graph. But overall, what I need from 0 to 1. 2, 3, right? I don't need the whole thing. So question, do you see those pieces that you have to shape? So it's a curve and x-axis, right? So we're looking at this triangle over here, and then we're looking at this triangle over here. That's what we have. Well, and from here again, it's not going to be difficult to find those. So a sub 1 will be 1 over 2, base is 1, height is 1. So it's 1 over 2. A sub 2, right, it's the same we had before. 1 over 2 times 2. Height is 2 again, so we'll get 2. So the total area will be again addition of these two, and it's what? 1 over 2 plus 2, so that will be 5 over 2, or 2.5 if you want. 2 and 1 over 2, right? Did you get the idea? So, overall, it's just another way to look at the picture. Now, here's the thing. Not every integral can be found using this method. You can only find integral using this method if the function resembles something that you have formula for. Again, triangle, do you have formula to find area? Circle or semicircle, you have formula to find area. Rectangle, right? You have formula to find area. Or maybe even trapezoid, we have formula, or trapezoid you can break into one. rectangle, right, triangle, you can do that. But not every single one. So don't get this idea, okay, I'm just going to use my calculator all the time to get the integral. It doesn't work all the time, okay? If I have some function, I don't know, some wavy curve or something, that's not going to work. So this blue specific method, it only can be used for specific pictures, triangles, rectangles, or squares, whatever we have formulas for. So that's this. So now we're going to work with the properties of integrals, because in the future this will be helpful to simplify a little bit our process of finding those integrals areas. And let's go with the first one. So we're going to go through a list of properties, and then we'll give you a couple examples that actually relate to this. But nothing will be big and new 100%, just the properties. So one of the properties is this. So we have integral of c f of x dx. Now what is c for us all the time? It's a constant, right? So the property is saying is this, that you can take this constant outside of integral. And sometimes it makes big difference if you move the constant. Like for example, maybe you want to move outside negative sign. So you want to keep function inside positive. Or maybe you want to pull out some greatest common factor. All of those things you should look, but sometimes it's just not a big deal if you pull it outside or not. Now the other thing I probably, again, I'm trying to remember from all of my classes if I said this or not, but the topic of section 5.2 is the definite integral. Now did I mention why we call it definite integral?
Definite answer.
Right, we'll get definite answer meaning what? A number. And that number means what? The area, right? Now later on we'll talk about indefinite integral. And with the indefinite integral, the answer will not be some number. The answer will be some function with x's and variables and all that stuff, okay? So right now we're talking about something where we have the answer as the area, okay? So, and really what that tells you that you have definite integral, that you actually have upper and lower limit. So what do you have? You have interval, okay? That gives you the area under the curve. So that's, that's this property. Integral from a to b. Then we, actually no, not a to b, a to c, sorry, fix this. Integral from a to c of f of x dx plus integral from c to b f of x dx. So what do you think by looking at this, what do you think the answer is? Well, what do you see? It says from A to C and then what? From C to B. So this will be from A to B. Do you see that? Yes, no. From A to C and from C to B. So where's C? In between, right? We're not saying in the middle, somewhere. So this is what we have. Now, if you look at the sketch, just to understand how it looks like on the picture, so let's say we have A, let's say we have B, and then we have some graph, let's say like this. So if we have C somewhere over here, we understand that we can have two pieces, and if we combine them, we have one, right? Now I have a question. So far we didn't say anything about the function. Like normally we say, if f of x is continuous on interval a, b, and all, the rest. So the question is here, can this function, y equals f of x, can be this continuous function? Or this function always must be continuous function? What do you think?
Well, yeah, if it has to be continuous,
thoughts? Again, I'll repeat my question because I want you to think. You see the picture, you see the property. So my question is, the way I put the picture looks like function is continuous, yes or no? So question, can this function be a discontinuous function and the property is still valid? Any thoughts? Now, you can answer this question easily if you go back and try and refresh what kind of discontinuous we have. So let's refresh. What kind of discontinuous do we have?
You've got
Jump.
Jump. All right, good. What else? I need the right name for that. How do you call discontinuous if you have a hole? Starts with R. Removable discontinuous. And the third one? Infinite. And what is infinite? What do you see on the picture when you say infinite discontinuous? Yeah, vertical asymptote, right? So those three discontinuous we have. So, again, removable discontinuity, jump discontinuity, and infinite discontinuity. So what do you think? So this property, again, is it going to work at least for one of those or for none? Or maybe for two, or maybe for three? What do you think? Okay, good guess, and you're right. It's not going to work for the infinite discontinuity. Okay. Now, also for some problems with the infinite discontinuity, it still might work, but that's the topic for Calc 2. Okay. Overall, we're not going to touch that side. Okay. Overall, we're saying for infinite discontinuity, it doesn't work. But do you think this can work for the removable discontinuity? How would you see this picture with removable discontinuity? Occupation. So how do I do removal? Come on. How do I do it? Where? C. So, can I still do it? And the answer is yes. I can still do it. I can find area from A to C. I can find area from C to B, and then what? Add. So, if you know that your function is discontinuous at C, and you know this discontinuity is removable, you can actually go backwards. For example, if you have something like this, you can break it into pieces, and in this case, you're kind of trying to avoid that discontinuity. Do you understand that? Now, let's put a little sketch, a little picture for the jump discontinuity, and let's see if that will work. So, let's say we have A, let's say we have B, let's say we have C. So let's say we have something like this. So this is what I have. Do you think this will work?
Where?
Yeah. Here's my question.
Yeah,
you
you
see
can
two
find
pieces.
You can find area.
So we put one over here, right? Right? So this is the area. And then you have the second area is over here. So can you still break the big area into two smaller areas and find area of each and add?
Yes.
The answer is yes. Okay, you can do it. So overall, as the concept of the area or integral is based on the concept of continuous or discontinuous, but we can still handle this if we have removable or jump discontinuity. But we cannot do this if we have infinite discontinuity. Okay? It's not going to happen because understand if we have infinite discontinuity, then what? you have vertical asymptote, right? And your graph is what? Approaching. So you really will not enclose the area for most of the functions. And again, I said for the most, because we have some exceptions, and that's for Calc 2. So did you get this property?
Yeah.
And the reason I spend more time over here talking about continuous or discontinuous, because you actually will have some problems where you have to make a decision. Can I do it or I cannot do it? And it's all based on being jump discontinuity or removable discontinuity. So that's this. The other one we have, the other property we have is this. Integral from a to b f of x dx. And like I said, we're using all of that. Right now it's just like a bunch of formulas or properties, but later on when we get to section 5.3, 5.4, we're going to use this. So here is the property. Now visually, if you look, what just happened?
You switch the A and B.
And for the negative sign. So what we see here, there's a possibility that actually you can switch your upper and lower limits, right? Was A, B, now it's what? B, A, but we have to put negative sign. Okay? And it's fine, this can be done. Okay, there's no problem. And first I have a question, kind of more like observation question. Well, let's assume that this area is positive. Because remember, area can be under the curve, can be positive or negative, right? So let's assume that the left side is positive. So here's my question. By looking at this, saying equal sign. So what I'm saying, positive area equals to negative area? How can you explain that? Why is all of a sudden still right, but you have negative sign? Again, let me repeat. We have equal sign, so we understand left side equals to the right side, yes?
Yes.
So the left side, again, remember I said assume it's positive. So how come it looks like I'm saying positive equals to what? Negative. Am I right or maybe I'm wrong? You're absolutely right. The integral itself, this one, integral from b to a, is negative. So then you get what? Negative times by what? Negative, and you'll get positive. And the reason it's negative, because of delta x. Remember the formula for delta x? What was the formula for delta x? B minus a over n, right? And we always assume that b is what? Larger, right? Now if you switch these, what do? You're going to say what? A what? Minus b. And in this case, delta x will be negative. And that's why integral is negative. Again, why a minus b is negative? Because still b is larger than what? A. Good simple. So we're going to use this property. Sometimes when we do this process, sometimes maybe you want to get rid of a negative sign. You just don't want it. We'll flip the upper and lower limits and you can get rid of the negative sign. Or sometimes in the process of calculating the integral, it can happen in the process, I'm not saying right away, it can happen in the process that actually your upper limit is smaller than your lower limit. So if you really, one of those people, nope, it has to be larger on the top, smaller on the bottom, you can just flip it and put the negative sign. Okay? But overall, kind of doesn't make a difference, but sometimes we do this. The next property we have is this. Integral from a to a f of x dx. Can you tell me what this is? What's the value? Why?
The point there's zero area.
Okay, basically what? If you look at the picture, think about the picture, no area, right? Because you have no what? Set, right? Alright, good. That's 0. So that's another thing that we have to look at. This one's easy to remember. So everything what we're talking about right now is just basically area. We're trying to think about integral as the area. The next one we have integral from A to B. Now this one is more specific. Sorry, it's c dx. I don't know what I was trying to write, but it's c dx. So integral of c dx. So this time integral of a constant. Can you tell me what that is? Let's think about picture. Can you calculate this integral? What is c here? Yeah, it's constant, right? Now, when I say constant, what that means on the graph? It's a horizontal line, right? You picture what you see here? You have a horizontal line on integral from what? From A to B. How that picture looks like. What's the shape? Just a rectangle, right? What area of rectangle? Base times height, right? Or length times width. What is my base here? B minus A. What's my height? You told me it's a horizontal line, so what is your height? It you see, right? So the answer here is C times B minus A. So if you still don't see this, little picture to help. A, B, and here's your C. So the only thing what I'm looking at with the small segment from A to B, because that's what I have. So if you look right here, here's your area, right? So here's your base, which is B minus what? A, right? B minus A, the length of your base, and height is what? C. The only difference, I just flipped it because it's more convenient to look at this, C times B minus A. Do you understand? So sometimes when we have a constant, quickly you can just use this kind of formula and get the area without anything special that we have to do. And the last property for the equality, meaning equal sign, is this. Integral from A to B. And inside them we have two functions. But overall, we don't have to be limited with only two functions. I can have many functions here, like f of x plus g of x minus h of x plus k of x, whatever I want to put. And the whole idea of this property is that you can actually split this into two integrals or three integrals depending how many functions you have. So we have integral from A to B, f of x dx, and then plus or minus whatever we have integral from A to B, g of x dx. So with this property, what we're saying if your function has multiple terms, and if you want to integrate that function, you can look at each term separately, not looking at the big function, because sometimes this can be big and complicated. But if I go with each term individually, I can turn this into a nice and beautiful, simple problem. So that's what we have right here. You understand? Now, let's take a look at one problem kind of related to this. And it will not be true algebraic math. You will see what we have right now. But this is just the beginning of trying to find what this area is. So for number, well, since we continue, this will be what? 4? This will be 5? I don't know. Okay, 4. So the question is to evaluate this integral using properties. And I really want you to pay attention to those little extras, like find the integral using properties, for example, or find the integral using areas, or find the integral using limit of Riemann sums. All those things will lead you to the same answer, but with completely different methods. So you have to be very specific the way you're doing it, because on the next exam, I will be very specific what I want you to do. It's not going to be just find integral, whatever you do, for some problems. For most of them, right, I'm going to say find integral, and you decided how you're going to find it. But for some problems, I will be very specific. So like over here, it says, find this integral using properties. So I'm not talking about go to limit of Riemann sum. I'm not saying graph it, you understand? I'm saying use properties. So when you look at this integral, the first property, what you see here, you have addition. So you can split this into two integrals, yes or no? So we have integral from 0 to 1, 4 dx. Again, don't throw away this dx, you're going to lose points, and mathematically it's wrong if it's gone. Plus integral from 0 to 1, 3x squared dx. So by using the last property, now we split this. Can we still use at least one more property? What do you see? Right. We take constant, that 3 outside. Now, eventually, when you have a little more practice of kind of doing this, all of these steps will be in your head, by the way. Okay, you know that you have to pull through, you know that you have to separate this. But right now, just going step by step. Alright, so that's all you can do, by the way, in terms of like going with the properties. Now we still can do one more for the first one, like this integral. Can you tell me what is this when you find this integral? It will be just 4, right? Now if you forgot, I'm really talking about this property right here. This is your 4 dx, right? 4 dx. So 4 goes outside, and then you get what? The base. And what we have here from 0 to 1. From 0 to 1, right? So what do you have? If I go step by step, you have 4 times 1 minus 0. You understand? Which is 4. So we're putting 1 minus 0. Plus 3 times. And now we have to find integral from 0 to 1 of x squared dx. Now here we have a little problem. Because we didn't see lots of methods like, let's do this quickly. The other thing is, for example, if you want to find this integral of x squared dx by graphing, you're really not going to have any shape with the straight lines. Remember, this is the parabola, you get a curve, right? So you will not be able to use any formulas to take care of this. So here's the thing. On the homework assignment, when we get to this like this, this is just the beginning, okay? So we understand not everything you know. They will say this. You should know what that is. It can be done at the beginning. And they're right, you should know what this is. Because I did this before in section 5.1. When we were looking for the area under the curve, which is x squared on interval from 0 to 1. Can anybody find this in section 5.1? What is the answer? For the exact area under x squared on interval from 0 to 1. What do you think? It's what? 1/3. It is 1/3. Remember I did this using limit, long process? So first we did what? From the right with 4 rectangles, then we did from the left with 4 rectangles, then we did midpoint with 4 rectangles, right? And then I found the exact area. So the answer to this is 1/3. Which is kind of bad, you know, overall to say, like, you should remember. The question is, why do I have to remember this? Right? But we don't have lots of methods, so they're trying to find kind of way out, give you more functions, but at the same time, to help you to know what the answer is without going too deep, which will be in the future. So, overall, we get 4 plus 1, which is 5. What else they can do, if they feel like they want to have more complex problem, they can actually give you little link. And with that link, they may give you a formula which you can use. Like, for example, they may say this. Well, you have to understand, if I have a book, I can open a book and find the formula. So they may say, okay, look at the page, this, number this. Well, what they're referring to, they will refer this formula. Integral from a to b, x squared dx equals b cubed minus a cubed over 3. Well, think about this. If you're looking for this integral using this formula, what is b? 1, right? So you get 1 cubed. What is a?
0.
0. So 1 cubed, 1 is 0 cubed is what? 1 and over 1. 3 and you have 1/3, right? Now, don't memorize these formulas. They will be completely useless in 2 lessons or maybe even 1 lesson, okay? You will learn how to apply calculus in terms of formulas, concepts, and you will learn how to find these integrals like in a second. This is what they're giving you just to make sure you will finish this homework assignment. Okay? So one way, again, what they say, you did this before, go and remember section 5.1, or they will say, here's the link, click at the link, you get this formula. Substitute A and B, and you will get your 1/3. Okay, this is just the beginning. Okay, so they're not going to try to push you memorizing anything. It's just a formula we'll use for now. So that's this one. And again, the beginning, not too difficult. Now we have 3 more properties with inequalities. 2 kind of intuitive, you can see them right away. The third one is more important than the first 2. We'll spend more time with the third one, but still I'll show you all of them. So one says this: if your function is greater than or equal to 0, for x is greater than or equal to a and less than or equal to b, well, basically what is this? It's just interval, yes, no? From a to b. But I have another question. If you understand what you're looking at, then you know what conclusion is, okay? Because what they're saying here, then integral from a to b, f of x dx, and then I'm going to pause right here because you're going to make a conclusion, what they really want to say. But what do you think this is? So what is f of x is greater than or equal to 0? Absolutely right. Just function is where? Sitting above the axis. Yes, can be 0, yes, no. But overall it's where? Above the axis. So tell me about the area. If the function is above the x-axis. It's positive, that's right. So we can say what? Greater than or equal to what? 0. So if you understand the concept, the little pieces, then you can lead or go to the right conclusion. Again, function is above the x-axis. What do you know about integral, which is the area? It's positive. You understand? So that's one property. Very simple, as long as you know what this is. Another one says this: if f of x is greater than or equal to g of x for the same interval, then integral of a from a to b, f of x dx, and integral from a to b, g of x dx. So what kind of relationship you can put between them?
Greater than, probably.
Probably, okay, let's delete that probably. Let's say yes. Why?
Because you're just expanding it. If you have that and you're just expanding it, so it should be the same.
Okay, well, you're just looking with your eyes. Let's just explain this a little bit more. So f of x greater than or equal to g of x. How's that look on the graph? So g of x is what? Higher, right, on the graph than what? G of x, right? Or they can touch somewhere, sometimes. So if your function is higher, then the function has more room where? Under it, right? You understand? So it means it has larger what? Area. So the sign here goes greater than or equal to. Yeah, and was right. Yes, the sign is greater than or equal to. But overall, think about the picture. Not like, well, this has to be this way, so that means that has to be that way. It's right, but not exactly 100%. Again, f is higher, has larger area. Do you understand? Okay. And the last property, what we're going to do, like I said, these are very intuitive. It's easy to see. The last one, a little bit more complicated. So this one says this: if f of x is greater than or equal to lowercase m and less than or equal to uppercase m, the same interval, and then we have then. And I'm going to write what that is, again, because it's a little bit difficult to predict. Integral from a to b, f of x dx, will be greater than or equal to m, little m, times b minus a, and here less than or equal to big M times by b minus a. So So simple question, well, how do we get these on the left and on the right side? Well, what are these? Where are they coming from? I understand what this is, right? I took integral of half of x, yes, no? Well, what do you think where this coming from?
It's the height, B minus A is the width.
So what did I do? I actually took integral of all of them, right? I took integral of this, I took integral of this, and I took integral of this. So basically, what do we have? I'm going to put arrow that you understand where this is coming from. This is coming from this. Integral of f. Do you understand that? That's what you get if you apply that property. Well, this one will stay because I have to deal with this. And the same story for this one. It will be integral from a to b, capital M dx. So again, if I have little m, we'll talk about this in a moment, what those are, little m and big M, and my function is inside, surrounded by those, I can just go with the integral and find what these are. So basically what this property is telling us, that actually you can approximate integral. Okay, you can approximate. You may not get exact value what that is, but at least you will approximate so you know what that area is. How accurate this is? It depends. But overall, not the best. But at least something than nothing. Okay, that's what we're looking at. So, first question is, okay, I put little m, I put big M. First of all, those are not little slope and big slope. Okay, just in case you think about little slope and big slope. No. What these are, you can treat them, for example, as horizontal lines. So your function will be sitting where? Inside, right? And again, we're talking about interval. Or even better, if you think about little m as absolute minimum. And big M, what? Absolute maximum. Now, why I'm saying this? Because sometimes it's difficult actually to deal with this function f of x. So you have to go back to chapter 3, actually 4, and think about how do I find absolute minimum and absolute maximum. We had this, okay, in section 4.1. How do we find absolute minimum, absolute maximum? We take the derivative, good, set it to 0, finish, next. Well, not exactly, I don't want you to do that, because you're looking for what? Absolute minimum, absolute maximum. You're not looking for local minimum, local maximum. So it's still valid. Take the derivative, set it to 0, find those numbers, those will be what? Critical numbers, right? And you have this again one more time. You take these numbers, substitute into the function original one, Also, don't forget about end points on the interval. Put them into original function, and then take the largest and the smallest. That's what we're talking about, absolute minimum, absolute maximum. Okay? Sometimes we have to do this. Why? Because you will not be able to limit your function with the numbers. These must be numbers. This cannot be x, and this cannot be x squared. You understand that? These are the numbers. So if there's no way you can limit your function with the numbers, like right away,
Good
you have to
afternoon,
actually
Nicholas.
find
Your name
absolute minimum,
is
absolute maximum.
baseball players.
So let me just
Mandatory
finish this
baseball
quick,
meeting
all right?
Wednesday, November 7th.
So one way, as I said, get the
Jenna
function,
101. For
take
player
the derivative, set it to
Jenna
0, and go with the
101 is
process.
during second
Or,
semester. She
if
has
you
not
have a
available
chance,
Please see her
try
for
to
interest
build
in
your
taking
function.
Industrial
So let me
maintenance
put the
program.
next example
Applications
right
for
there.
the
This is the
industrial
last one.
maintenance program are now
So
available.
what I'm
Have you
trying
ever
to
talked to
do,
the kind
I'm
of career
trying
one of our local
to
plants specialized
approximate this interval. Integral.
amalgamated sugar, high desert milk, Fabrical, McCain's Transystem Performance,
So I'm trying to find numbers, right?
and many
Where
others.
that
Your
area will
counselor,
sit.
Mr. Lloyd, or Mr. Hayes, pick up an application.
Using that
Application will
problem.
be due by
Now,
Friday
on
after
the
midnight.
website, they will give you the link. You can click on the link and you will see the problem. On the exam,
Key
next
club.
exam,
We'll be
the
having a
last
meeting
one,
this
number
Thursday
4,
during first lunch. Please meet
I
us
will
at
give you the
room
problem, so you
221.
don't have to
We will
memorize.
be discussing the caring
So
insurance.
first of all, if I am this
If you
is
cannot
what-
make it,
let's put
stop
this
by
way.
and see
If I decided not to go with absolute minimum, absolute maximum, in the process of doing the
Mr.
derivative,
MHS,
I
medical
actually
student,
can try
Mr.
to build
MHS
the
is making a
function.
return this fall on November 13th.
Now, what is being
Any
built
student
the
who are
function?
interested
I
in
will start with
competing,
this.
sign up by
My
tomorrow
x
in
is
Mr. Ryan.
between 0
And anyone
and 1.
interested in
You
student work
understand where
at
they're
the
coming
Mason
from?
Harwood or any
My
BPA
x is
member, they
between
are
what?
only $10.
0, 1.
Seniors, all
And what I'm
seniors
doing
planning on
with this s,
graduating
I'm
with their
trying to
associate's
work,
degree in
manipulate
Brooklyn
with all of
for
this
Friday,
to get
November
to
9th,
this.
2018.
So I have x, right? But my x is not x.
Professors, the
My x
first
is
day
what?
of practice will be Monday, November 12th
Excellent.
at 3:30 in the Western Room. We will also be having a
You see that?
parent
So what do I do?
meeting
I
on the
will
12th at 7 p.m. in the library. Everyone expects
square
to have
everything
at
that I
least one
have.
parent in attendance. That's all for today.
Remember I said I'm
Minimum based
building
on
a
staff.
function?
Remember, you matter and
If
chances
you
to
don't
make
want to
you.
build the function, well, you get rid of set it to 0. I'm telling you what to do straightforward, okay? Process. Next. I don't have just x squared. What do I have? Negative. Multiply everything by negative. Don't forget to flip the signs. 0 greater than or equal to negative x squared greater than or equal to negative 1. Now, I really hate my crocodiles, so-called, looking this way. I'm going to flip the whole thing. I don't like it pointing the wrong way. So I will move this around like this. This is normal, okay, from smallest to largest. So this will be negative 1. This will be 0. Do you understand the step from here to here? I just flip the whole thing, keeping the signs and everything. Well, almost there. What do I have? I have negative x squared, right? But what do I have? E to that. So what do? You apply e to each piece. So you have e to negative 1, you have e to negative x squared, and you have e to 0, right, which is what?
1.
I'll put equals 1, okay, like this. So here's the thing. This is your f of x. This is your what? What's on the left side? This is your little m, which is what? Absolute what? Minimum. And here, 1 will be what? Absolute max. So you have your little m and you have a big M. And the last step, apply the integral. Because remember, this is not the end. And many students will stop right here when they do the problem. Not yet. You found what little m, you found what big M, then apply integral, and then you will finish the problem. And that will be easy. So, applying quickly the integral from 0 to 1, e to negative 1 dx. Integral from 0 to 1, e to negative x squared dx. Integral from 0 to 1, 1 dx. So tell me, what is this? Now remember, e to negative 1 is just a constant, right? What's the length of interval? Just 1. So the answer will be just e to negative 1. And what's on the right side?
1.
It's
1.
1. And you're done. That's it. So you know the area for integral will be somewhere between these two numbers. Okay? So tomorrow I'm going to add one extra piece to this. Not actually solving anything, but kind of a comment. I know time is up, okay? So I will add some other things. So probably, Monica, your exams will arrive tomorrow, because that's how Connect works. And then I will grade them. And I'm just waiting for the girls' score. But I promise I will grade them before you know.